article is related to phase field simulation of fraction mechanism mechanics with energy degradation and damage of coupling in MATLAB. So, in this article, basically, we have developed the phase field modeling that emerged as a powerful and versatile framework for the simulating of vector process, process without the need of explicit crack tracking. Okay. So, so the fracture behavior is represented through a continuous damage variable that smoothly transition between intact and fully broken states. The governing equations couple elastic deformation with damage evaluation driven by the strain energy density and fraction toughness. So the numerical simulation basically demonstrates the initiation, growth, and interaction of cracks of from an initial flaws. In this paper, the results highlights the capability of the proposed framework to capture complex fracture patterns and damage localization. Model basically an effective computational tool for studying the dynamic fracture phenomena in brittle materials. So the abstract with the introduction is written in the introduction. I have explained like how the initial damage field with the damage evaluation, damage profile according to different phase field modeling of dynamic crack growth using Alan Cahan equation. Alan Cahan was one of the scientists who proposed the type of phase field equations provide an efficient, robust means of modeling damage evaluation in brittle materials as well. Okay, so here is a material properties which used in the energy degradation function, in which Young's modulus equation, Poisson ratio, shear modulus, Lame parameter, critical energy release rate, and the length scale parameter are also used. So this is the background with the phase field approach to fracture mechanism. In the fracture mechanism, I have added the parameters of the phase field model, which I have used in the MATLAB code to develop the phase field model. Okay. So the Allen Cahan type damage evaluation basically, Allen Cahan was one of the scientists who developed the equations that are describe the damage evaluation driven. So the Allen Cahan type equations basically normally used for the damage evaluation driven by local energetic forces. So these equations balance the strain energy released with fracture resistance while ensuring the irreversible of the damage. Okay. So next one is basically the numerical implementation of objective of the study. Yes, in the numerical objective is that we have just added the MATLAB based computational framework which is developed to simulate the crack nucleation and propagation. The model incorporates the elastic deformation, damage evaluation, and energy degradation as well. So here is the role of energy based fraction criteria with the dynamic loading and crack evaluation and importance of length scale regularization. In the importance of length is that this parameter controls the thickness of the diffused cracks zone and prevents the mesh dependency. Without regularization, numerical solutions may become unstable or physically unrealistic. So the visualization and interpretation of damage evaluation is basically damage two-dimensional contour plots and three-dimensional surface representations enhance the physical interpretation. So these visualization techniques aid in validating model behavior as well. Then scope and contribution of the present work is that model integrates the Allen can damage valuation with the linear elastic deformation in a unified setting, and a finite difference numerical implementation is adopted for simplicity and efficiency. Problem statement is written, then the mathematical model explain and write, and in the mathematical model I have write all the equations used in the, especially for mechanical equilibrium, elastic strain, energy density, damage evaluation, Allen-Cahan equation especially. Okay. So this is a methodology in which how I have used the material properties such as Young modulus, Poisson ratio, fraction, toughness are specified along with the base field parameters, including the mobility coefficient, gradient energy coefficient, and length scale parameter as well. Next one is simulation domain parameters. These are the parameters used in the MATLAB, and the MATLAB simulation is here. Initial damage field at different time scale like 1/4 of the total simulation time. This is a half time of damage field at half time field. Damage force of full time field according to the crack propagation. This is the damage profile along center line. Damage evaluation over time. 3D visualization of final damage field. Crack propagation sequence as well, and the results and discussion with the conclusion and references are added. Let me just open the MATLAB file for you. The laptop is a little bit slow, that use fix. Is this the Okay, so just a second, let me just open the greens version. MATLAB demonstration, downloads. So here is the code of this field demonstration. So you just need to run this section first. See, in the command window you will get the output results accordingly. Progress should be 100%. Simulation completed. Now output results will be displayed. See, these are the output results accordingly. Damage field. Then this one, this one, this one, this one. Okay, all the output results are displayed here. Just a second. See, these are the damage profile center line. And let me just also show this one also. 3D visualization of final damage field. Damage valuation over time. This is a crack propagation sequence as well. Okay. So if you need to ask anything, you just ask me. I will answer your questions. Thank you.